This is chapter 6-4, rhombus, rectangles, and squares. What we're getting ready to get into are more quadrilaterals. Quadrilaterals, again, four-sided shapes. In particular, we'll look at these particular three quadrilaterals that are actually parallelograms. So that also means that their opposite sides are parallel, and their opposite lengths are congruent, and their diagonal angles are congruent. So what would that look like? For example, the first special type of parallelogram, remember parallelograms are quadrilaterals. The special type of parallelogram is a rhombus. And a rhombus is a parallelogram that has four congruent sides. That means that all four of the sides will have the same length. So if this is A, B, C, D, and AB is 8, that automatically means BC is 8, CD is 8, and AD or DA is also 8. Again, this special type of rhombus means that all four of the sides are congruent. How do we know it's a parallelogram? That means that AB is parallel to CD and BC is parallel to DA. Remember, the diagonals on the parallelograms are congruent. So angle A is congruent to angle C, and angle B is congruent to angle D. That's a parallelogram. But the special type is called a rhombus, where all four of the segments are congruent. Let's look at the next one here. I just threw a remember on here for all three special types, which I've already stated. Parallelograms that we learned. Remember the rules for a parallelogram: opposite sides and pairs are congruent. Okay? Let's look at the rectangle. The rectangle is also a parallelogram. What's special about the rectangle is that it has, or will have, four right angles. All 90-degree angles in the four corners. That's what's special about that one. Next, we have the square. A square is also a parallelogram, but what's very interesting about the square is this type of parallelogram is a rhombus and it's also a rectangle, because on a square, all four of the side lengths are congruent, and all four interior angles are right angles or 90 degrees. Again, what's special about the square is all four of the side lengths are congruent to one another. So this is M, N, B, C. That means that MN is congruent to NB, MN is congruent to MC, MN is congruent to BC, and so on and so forth. Angle M is congruent to angle B because it's a parallelogram, and angle N is congruent to angle C. But what's so special about this, angle N is also congruent to its consecutive angle or next to angle M. So N and M are both congruent to one another on a square. Right? Here's a special type of diagram. You'll find this in your book as well. Okay, hopefully you remember these type of shadings here. On the shadings, we have the three special type of parallelograms. We have a rhombus, and we have a rectangle. Okay, what you should notice about the three, and in particular the one, which is the square, a square is actually both. It overlaps. It's a rhombus and a rectangle at the same time, which I stated previously. Okay? Moving forward, some corollaries. That word is just one that you say it 10 times fast. It can be a tongue twister. So let's look here. Some corollaries. The rhombus, what it says, a quadrilateral. When we're talking about a rhombus, a quadrilateral, a four-sided polygon. A four-sided polygon, or quadrilateral, is a rhombus if and only if it has four congruent sides. Here's the second one. Rectangle. This particular corollary is a quadrilateral if and only if the rectangle has four right angles. If and only if it has four right angles. Next, a square. This particular corollary is a quadrilateral If and only if it is both. It has to be both. The key word is and. If it's a rhombus and it's a rectangle at the same time, it has to be both, not just one. Okay? Here's some theorems for you. Theorem 611. There you go. A parallelogram is a rhombus if and only if its diagonals are perpendicular. So, if this is going to be a rhombus, remember what a rhombus is what? All of the four sides are congruent on a rhombus. That's the important thing about the rhombus. But you need to know, if I decide to draw the diagonals, so BD and CA, if I decide to draw diagonals, when I draw the diagonals on a rhombus, where they intersect, these angles will all be 90 degrees. They will form right angles. Okay? So that means ABCD is a rhombus if and only if AC, which is the diagonal, and BD intersect. They will form 90-degree angles. You need to make sure you know that theorem. 611. Okay? Finally, and the bell's getting ready to ring, on 612, a parallelogram is a rhombus if and only if its diagonals, here we go, are going to be bisectors. So here we go. On ABCD, it's a rhombus if and only if when you bisect AC, angle DAB. And I'm going to pause here and I'm going to do a part 2 for you.